Good morning, everyone. Today we're going to uh, continue our discussion on multiple linear regression. Let's have a review of what we did last time. We loaded the wage data set last time. So how do you load the data set in a particular data set in R? Just make sure that I loaded the wage data set in Canvas. Please download it and save it in your R project. Okay, make sure that it's in your R project for easy loading. Okay, so you can see here that I have wage.csv. Okay, I'll give you a few seconds, please. Kindly chat if you have already wage.csv in your saved in your project. I hope everybody will respond, please. Yes or no if you have wage data set. So I'll assume that everyone does do not everyone does not know yet uh, how to load a data set in R. Again, a yes or no, please. If you have saved the wage data set in your R project. Okay, good. Thank you. Let's wait for the others. Everyone, please kindly reply. Counting four only. Okay, thank you. May I request everyone to respond, please? Okay. I'm getting only a few responses. 2, 3, 4, 5, 6, 7. 7 lang, class. How many are you now? You're 22. Again, everybody please respond. Okay, so once you have uploaded the data, in this case, wage data set in your R, in your project specifically, we can now load the data into our into the RMD file that we are working on, class. So I'd like us to load that data. We're creating this object wage, and then we're going to use read.csv. By the way, class, let's also, I'm sorry, I forgot to tell you to, let's load the other packages here. I just copy this. I'm sure you did this before. So I'm just going to use Pacman. So this is from the other file we were working on. Okay. So let's load mass dplyr and kindly include here OLSRR. Okay, I think I better share this with you. Control C. Okay, and make sure that Pacman is loaded. Packages and Pacman. Okay, Pacman is not loaded. I'll load it. Pacman, their library Pacman, and then run this. So it will load these packages, mass, dplyr, ggplot2, car, caret, etc. Okay, everything okay? check please if OLSRR is already installed. OLSRR. There you go. OLSRR. Okay, so in order for us to access the data, we use read.csv, and then the reason why we upload the file, save the file in your project, is that it makes the code to load it to your RMD very simple. Just this read.csv and then identify the file name. You don't have to define the file location. No more, because it's already in your project and you're working in your project. So if you load this, Control Enter, and then view. Okay, so this is our wage data set. You have 8 columns, so that you have your 8 variables, 526 entries, which means there are 526 observations. Okay, so what are the variables here? Education, experience, tenure, race, gender, civil status, number of dependents, and hourly wage. So this is all about the hourly wage of each individual in a certain company. Okay, the education stands for the number of years. I'm not sure if this is in a certain company or the average hourly wage in a particular area. Okay, so but maybe it's in that company, but it doesn't matter. And then experience is the number of years of experience. Tenure, it's so this must be a company data. Tenure has something to do with the number of years in that company. Race, gender, and civil status are all categorical variables. Number of dependents, and then hourly wage. Hourly wage is our variable of interest. We would like to predict hourly wage using these independent variables. Okay, I will not discuss everything that we discussed last Monday. I'll post the video, okay, and leave you class to look at the other things that we did last Monday. Now, this one, we did not do it last Monday. So I'd like you to copy this code, okay? And then I'd like to go here, class, back to the data. Now, when we do multiple linear regression, we want that the dependent variable is highly correlated with your independent variable. We want it to be highly correlated. Of course, your dependent variable should be quantitative, okay? Which means that the variable should be continuous in nature, which means that it should be able to take on decimals, okay? So we can regress hourly wage on education, experience, tenure, number of dependents. Now we can, just like in the Boston case class, we can, if you recall, we can regress hourly wage even on categorical variables. However, we have to make sure that these categorical variables are factors. So if we get the structure of our data, structure of wage, we can see that race, gender, and civil status are not factors. And we learned last time that we have to convert it into factors. Okay, so here we did this last time. We converted so we accessed the race. Okay, we said that we cannot directly access race. We can only access it through wage. So if you type wage and then dollar, you can see that you can access race here, race. Okay, and then the function to use is as.factor, wage race. So if we run this three, okay, and then run structure again, structure of wage, we can now see that gender Race, gender, civil status are now factors. They have two levels. Okay, non-white and white. You can of course see what the levels are. We learned that last time. Let's do that quickly. So for example, for race, we can create say tab 1, table 1, alt minus, then table wage race, tab. Okay, and then maybe let's prop that table, then tab 1 to create a proportion. Okay, then we can copy this, Control C, Control V, Control V, create another table, tab 2, and then raise. Next is dollar gender, arrow down, tab. Okay, and last, this is tab 2. Just like to get both the distribution and the proportion. Dollar, and then it's your civil status, tab 3. Okay, so this should be tab 3, sorry. Okay, so we both got a table. We have to print tab here. I'm going to, okay, to print tab, I just write here tab 1, because just by writing tab 2, it will not print. I want it to print automatically, and tab 3. Okay, so I think this is okay now. Run. So there you go. Okay, so we can see here that non-white, 54 observations, white 472. So that's around 10.3% are non-white and 89%, 89.7 are white. For female, 252, 274, 47.9 and 52%. The male slightly above the female. For married, so there are more married people in this sample, 60%, 39%. Okay, I hope I don't need to, I think I don't need to review that because we already did that before. Okay, so before we do regression, I was saying that we would want the dependent variable to be highly correlated with your independent variable. Okay, but not the but okay, so let's run this first. Okay, so let me just use first core wage. So let's plot first. Let's get the correlation of wage. Control enter. Oops, wait. Ah, no, okay. What core plot? What was that? Okay. Let me see. Core plot. Is it core plot? Error pa rin, no? So, say I'll dispense with this first. Okay. And then dali class, So from the psych package, na-load ba natin si psych package? Hindi, no? Okay. So kindly check class if I'm sorry, I forgot to load the psych package, which is used for descriptive statistics. Psych. Okay, so kailangan natin i-load to class. If you don't have it yet, class, kindly install na lang, no? For those of you who have it, make sure that you load it. I'll give you a few seconds, class, to install the psych package. You should have placed it here. Psych. Okay. Have you gotten it, class? Have you loaded the psych package? Okay, thank you. Waiting for the others. By the way, class, I'll inform you by Sunday if I'm able to meet you face to face, okay? Otherwise, if my condition does not improve by then I'm afraid we'll have to still meet online. And again, I'd like to apologize for that. Okay, so let's use here, class, pairs.panels, Control C, Control V, and then let's use wage. Okay, we have the wage data set. So from the site package, let's use pairs.panels, Control Enter, and let's see what happens. You can see here, class, a correlation plot. From your basic stat class, you know that correlation is a function that tells us of the linear association, the strength and the direction of the linear association between variables. You can see here the site pairs.panels. Let's take a look at how to interpret this diagram. This is education. The diagonal class, you can see here, education, experience, tenure, race, gender, civil status, number of dependents, and hourly wage. The diagonals represents the histogram of of each individual variables. You'll notice that race, okay, you can see the biplot here. Okay, because remember that these are factors, and in our case, dalawang levels lang si race, gender, at saka civil status. If it was 3, then you should have seen 3 plots, three bar plots here. Okay, kaso only 2. Okay. How about this one, class? Education. This is the plot of education. This is the histogram. You can see that the majority is in the middle. Okay. So experience naman, the more majority is on the most of them are lesser years. Konti lang yung ano no yung matagal na sa company, no? Then for tenure, same thing. And the number of dependents and hourly wage, same thing. Mostly on the low end. Okay, so that's the histogram of your dependent variables. Now what's this? This is a scatter plot class. Scatter plot. Okay, on the y-axis is education. On the x-axis is experience. So here, class, you go down because we're here, right? We're here. Okay, let me just draw that for you to better understand. Okay, so we're looking at this plot, right? Take a look up, education. So that means that this is your education is your y-axis. And then take a look to the right or to the left, you have experience here. So that means that your x-axis is experience. So that's the plot of education and experience. Okay, and you can see that the line here, okay, shows the correlation. and it's going down, which means that there's a negative correlation between education and experience. So what does this tell us? The more educated, as education increases, okay, experience seems to go down, or as experience goes up, education goes down. Okay, at least that is for this data class. We're not concluding that this is for all the data. For this data, there's a negative correlation between education and experience. Okay, so that's how you'll interpret this class. How about this class? Notice that the line is practically flat, which means that there's no correlation between education and tenure. No correlation. This one class, okay, this three, you can see the strange correlation here. The correlation between a continuous variable education and a factor categorical variable, this doesn't make sense because you cannot create a correlation between a numeric variable and a character variable. This only this becomes, for example, race becomes a dummy variable where we assign 0 or 1, but it's not actually numerical. So no sense interpreting the correlation of education with race, gender, and civil status, and for that matter, the others class. If you take a look at experience here, this is the correlation between experience and race. So notice that it's flat, practically flat, practically. This one has something going on here, but we don't put any. Sorry, that's already gender. So experience with race, experience with gender. Sorry, experience with civil status. Yes, this is also factor. They don't give us any meaning. Okay, so this one is actually in terms for the correlation plot. We don't need this. Okay, let's go to the others class. Let's focus on this now. Hourly wage. Okay. So if I go, so this is my y-axis class, hourly wage. Okay. Then I go to the left here, number of dependents. So what do we see here, class? What can we see here? What's this negative 0.05? What's that? You notice that the correlation plot has actually two parts. The upper part and the lower part. The upper part contains your correlation, the measure. The lower part contains your scatter plot. So the plot between hourly wage and number of dependents is this one. So you notice that it's flat, which means that there's no correlation at all. There's practically no correlation. And we can see that quantitatively it's negative 0.05. So very low, class. Very low. Okay, and then I'll skip civil status, gender, race, because they don't mean anything. How about this hourly wage and what's this? Tenure. Right? Hourly wage and tenure. So what do we find here? The correlation is also practically like a straight line. So that's quite, okay. Tenure. It's sloping a bit, but not that much. Tenure and hourly wage, and the slope is 0.35. Okay. For hourly wage and experience, where's that? Here. Experience and hourly wage, also not that strong. Okay. And the correlation is only 0.11. The one with tenure seems to be going up here. So there's a semblance of a positive slope. Here, class, it's flat, just like the number of dependents. So it's 0.11, which means very low correlation. And lastly, hourly wage with education. Here, hourly wage. And you can see here the plot, okay? There seems to be a trend going up. And then the correlation is 0.41. Okay, so among the independent variables class, it seems that education has the highest correlation, followed by tenure, okay, followed by, okay, these are of no consequence, followed by, okay, experience, and then, what's this? Wala to. And then, see, number of dependents. Okay, so if we're going to choose only one predictor, then most likely the best predictor will be education because it has the highest correlation with your hourly wage. So as I said, we want the correlation between the dependent variable and the independent variable to be high. But we don't want this. 0.5. What's that? Correlation between experience and tenure. Why don't we want a high correlation between your independent variables? We don't want class to have high correlation between your independent variables is because the reason for that is they will be competing in trying to explain your dependent variable hourly wage. Okay? So if the correlation between two independent variables are very high, and then you include them in the model, it will be very difficult and challenging to disentangle the effect of one variable on hourly wage versus the effect of the other variable on hourly wage. Okay, we will be having difficulty in disentangling how much of the variation of your dependent variable can be explained by the two independent variables. So usually class pag ganyan, that's why remember last time we had, I think I did mentioned multicollinearity, did I? If not class, that's another important assumption, the assumption of multicollinearity, which means class that your independent variables should not be correlated with your independent variables. Independent with dependent, check, very important. Good to have high correlation. Independent with independent, X class, X. We don't want them to have high correlation. Okay, otherwise we'll have difficulty in separating or disentangling how variable one, independent variable one, is affecting dependent variable, and how independent variable two is affecting or explaining the dependent variable. So that becomes a challenge. Okay? All right, let me pause for a while, class. Feedback naman, please, class. I would appreciate your feedback if this is clear, if this illustration is clear, class, please. I'll appreciate feedback from you, class. Okay, thank you, Jerry Lane. Thank you, Gab. Ryan, thank you. Hindi lang class, may tumatawag na estudyante. Let me just close the Samin. Just wait. Where's my... Hindi ko makuha yung ano. Oh, nako. Moment class, ha? Hindi lang. Okay. Oops, mali. What happened to my... Hindi ko na makita yung arc ko. Sorry, class. I request students not to call. Sabi ko mag-chat na muna kasi katulad nito, nagkaklase tayo na-disturb tapos nagulo na ako. Hindi ko pala na-pause yung recording. Okay. Anyway, so where are we, class? Here. All right. So so when we use pairs.panels, class, it's useless to include race, gender, and civil status. That will only crowd the that will only include the factors which are of no consequence for your correlation plot. So what we do here, let's create another object called wage one, and then we remove the fourth up to the sixth column. Okay, fourth up to the sixth column, class, so that we have only from education up to hourly wage without race, gender, and civil status. That way, we can create now we can create again the pairs.panels. Okay, so let's run this, class, and then run this. Okay, and you can see now it's clearer, and so there's no more quote unquote noise in your output. Okay, so same thing, class, same thing. On the lower part, you have your
Sir,
scatter plot. Yes?
sir, parang
sorry.
hindi po nag-aano yung
Oo nga,
screen.
ano. Yeah, sorry. Yan. Okay, let me repeat the process, class. So I was saying here,
Wala pa po, sir.
wala pa?
Wala pa po.
Share. How about this one? Is my screen sharing
Wala.
now?
Wala pa po, sir.
Sorry. Yan.
Same lang din po, sir. Naka-block pa rin po.
Bakit? What happened?
Lagay po, sir, post screen sharing.
Naka-pause ba ako?
Yung nakikita po dito
Sorry,
sa...
to resume. How
Ayan,
about
sir.
that?
Okay na po.
Yan, okay. Sorry, sorry. I'm sorry, I got distracted by the continuous ringing from a call of a student. Sabi ko, wag muna tatawag kagad, mag-chat lang muna. Okay, anyway, that's not your problem. Okay, so ito, class, what I did here was to remove create another object, no? Wage one. Preserve yung wage para kasi gagamitin natin yan. So don't just, sometimes you have to think, if I'm creating a new object, do I have to overwrite the existing one? Or do I have to preserve it so that I can access it later if I still need to use it? Okay, because I could have used here wage, I could have removed one. Okay. But if I did that, mawawala na si class, mawawala na yung race, gender, civil status. Kakailanganin pa natin yung sa regression later, no? Okay, so just create a new object, wage one, and then remove the fourth up to the sixth column, okay? I've run that, class, and then use the pairs.panels again, this time for wage one. And if you run this, you'll have this. You notice now that it's cleaner because you don't have now the factors that are really not important for correlation. Okay, so again, on the upper part, you have your correlation, the value of your correlation. On the lower part, you have your scatter plot. When you say scatter plot, it's the plot between two variables. And then for the diagonals, you have the histogram of your individual variables. Okay, we have discussed what this means. We can also use another plot, this one class, GG Ali. So I don't think did I ask you to, okay, no. So check your class packages, si GG Ally, okay, and make sure it's checked. If it's not yet installed, make sure to install it, class. So I'll give you a few seconds. Okay, I'm sure you know that already. Okay, and when you're done, class, kindly please chat so that I know when to continue. Okay, thank you. Others, please. Okay, thank you, John. Thank you, Jerry Lane. Waiting for the others to reply. When you respond, class, please share to everyone. Okay, good. Thank you, Adrian. I hope I get a higher percentage of response, class, because I'm not even getting 50%. So thank you, Ryan. Apat pa lang out of 22. So that's a very poor batting average. So less than 20%. How about the others, class, please? Apat lang? Okay, good. A few more seconds, class, and then I continue. Okay, thank you. All right. So let's continue, class. Okay. So what was the GG ally for? Because GG ally, class, yung functional GG pairs is a very good correlation plot. So let's do GG pairs wage one using GG ally, a cleaner, a better looking. Okay, here, class. Okay, I find this better, and it's better also because you can see here there are stars here, class, which means it tells us if the correlation are statistically significant or not. So three stars here, we know what that means, class, significant at 0.001. For the others, okay, no stars, which means that it means that their correlation are practically zero. Okay? Kasi not significant means, remember, class, that this is a hypothesis also. When you're getting the correlation, you're you have this hypothesis that the correlation between 1 and 2, asset 1 and 2, or variable 1 and 2, is equal to 0. Okay, so if the p-value is very high, okay, which means it's not significant, just like this one, class. No stars. No stars, class, means that your p-value is greater than 0.05. So what does that indicate, class? What's the inference here? We fail to reject the null hypothesis. Okay, that your correlation is equal to 0. So all of these correlations that do not have asterisk, okay, we are unable to reject the null hypothesis there that the correlation is equal to 0. Okay, all right. So I just wanted to share that with you. All right, hope that is clear, class. Now we go to the main lesson, which we already started last meeting. So what we did was, what we're doing is we're creating this model called mod 1, okay? And we said that LM is the linear model, hourly wage dependent variable, tilde, which is regress or associated with. You have your all your predictors. How many predictors? 1, 2, 3, 4, 5, 6, 7. And then you identify the data, which is equal to wage. Okay, of course, don't use wage 1 here, class. No? If you use wage 1, then that will give an error message, because it will not find race, gender, and civil status in wage 1 data set. And then we summarize this. Okay, so let's run this quickly. There you go. And we started discussing this last time. Okay, so we interpreted education very quickly. Okay, 0.57, and it's highly significant, 3 stars, significant at 0.001 here. But so that's highly significant. And it means that for every 1 unit, education is in years. So that should be read as, for every 1 year increase in education, there's a corresponding $0.57 increase in hourly wage. Hourly wage is in dollars. So we interpret this as $0.57 increase in hourly wage. And then we include, what do we include, class? Ceteris paribus. Ceteris paribus. Okay, what does that mean, class? All things being equal. What does all things being equal mean? You notice that my statement is for every 1 unit increase in education. So we increase education by 1 unit, or by 1 year in this case, but all the others remain the same. We're not increasing any of them. Okay. The 0.57 here is only the effect of education on hourly wage. It does not include the effect of the other variables. Okay, that's what we meant by ceteris paribus. 1 year increase in education, increase of hourly wage on 0.57. Okay, and as recall, class, that the null hypothesis here, is that your beta 1, which is your coefficient, is equal to 0. Okay, so what's our inference? We reject the null hypothesis that beta 1 is equal to 0. We have strong statistical reason to believe that it is a value other than 0. In fact, the average value is 0.57. Okay, class? Hold on. Okay, now let's go to experience, class. Experience is a dot here, class, and that is significant only at 10% here. So if we strictly follow the alpha level of significance to be 0.05, if we follow it to be 0.05, okay, then we're going to reject this, class, kasi 10% to eh. P-value is 0.07 and it's bigger than 0.05. So let's just maintain that as our as our level of significance, our alpha. So 0.07 class. So this one, the null hypothesis there is beta 2 is equal to 0. Beta 2 is your experience. And our inference there is we fail to reject the null hypothesis that experience has a marginal effect on hourly wage, or that beta 2 is equal to 0. Ceteris paribus. Okay? So that's the interpretation there. Tenure, also highly significant, 3 stars, less than 0.001. Ito. This is very, very small, no? 0.00000, so 9 zeros and then 147. That's what this means, class, e to the negative 10. You put point and then 9 zeros and then 147. Okay, so that's practically 0. So what's the interpretation here? For every 1 year increase in tenure, there's a corresponding 0.14 estimate around the lang, $0.14 increase in hourly wage, class, ceteris paribus. Okay, how about number of dependents, NumDep, class? NumDep is not significant, no? So we cannot say that for every one unit increase in NumDep, there's a corresponding $0.15 increase in hourly wage. Okay? So hindi siya significant. Okay, punta tayo, class, dito sa sa mga factors. This is interesting, class. If you recall, class, si race, 2 levels yan, di ba? White at saka non-white. Okay? And please don't forget that when we convert this into a factor, you are converting it into a dummy variable. Okay, ang tanong, ilang dummy variables to? When you say dummy variables, you create zeros or 1. Pwede yun, no? Yung iba 1 or 2. It really doesn't matter, no? So the usual is to create 0 or 1. So dummy variable. Ang tanong, ilang dummy variable to? Ilang dummy variable, class? Come on, we already discussed that before. Quickly, I hope you still remember that. Please do not forget that. How many dummy variables? Please. How many? Okay, if you forgot, class, please don't forget, class. Ilang levels ba to, class? Ilang levels? 2, di ba? White at saka non-white. -1, class. Always, if you have 3 levels, when you say levels, class, ilang types ng factors? Kasi kunyari, kung year level, again, yung example natin, frosh, sophomore, junior, senior, graduating, kunyari, 4, 5 sila, 5 levels. So, ilang dummy variables yun? 5 minus 1 yun, 4. Ibig sabihin, mag-create ng 4 na na panibagong variables. Kaya ang lalabas sa regression output natin, merong 4 dito na year level. That's what I'm meaning, class. Kung ilang dummy variables. Itong race, class, white or non-white lang yan. Okay? So how many dummy variables? 2 levels minus 1. So isa lang, class. Kaya nga tinan nyo dito, class, race, white lang. Diba? If you have 3, for example, white, non-white, tapos sabihin natin, kunyari brown. No? Okay? So what happens, class? Ilang dummy variables ang ilalabas dyan, class? 3 levels minus 1, you'll have 2. Ano yun, class? What will that be? Ganito gagawin ni R, no? Magdi-default siya, titingnan niya which is arranged alphabetically first. I'm not asking which appears first in your data, which is arranged alphabetically first. If you're going to sort the data, ano yung mauuna? Si brown, class. So si brown will be your benchmark variable. Ibig sabihin siya yung magiging 0. So what will happen? What will now happen, class, to the dummy variable? So magkakaroon tayo dito ng race na non-white, race na white. Si brown, class, hindi siya isasama, no? Kasi siya yung benchmark. So, dalawa lang. So, kunyari yung data natin, white. Kunyari white, brown, non-white. How will this be reflected in your dummy variable? So, si white, under this column non-white, 0 siya. Pero dito, 1 siya. Si white eh. So, ganun din dito, 0, 1. Si brown naman, hindi siya white, hindi siya non-white, hindi siya white. Kaya 0, 0 siya. Si non-white, 1, 0. So, were all the cases, class, were all the levels captured? Yes. Yes, they were captured using two dummy variables. Ngayon, pag nagdagdag ka pa ng big dyan class, magkakaroon tayo ng dummy variable trap, magkakaroon ng multicollinearity, and the model will not work. Okay? So, ganun yung class. Kaya, it's important to understand ano nangyayari sa dummy variables. So, yung race natin class, dalawang levels, white, non-white. Okay? So, ilang dummy variable yan? Isa lang. So, pag lumabas yung regression, race, ganun lang. Hindi race, tapos may race pa. Okay? So, sino lalabas class? So, tinan nyo class, white, non-white. Sino alphabetically mauuna? Si non-white. Therefore, siya yung magiging benchmark. 0 siya. Okay? And therefore, ang lalabas na output dito is race white. Yung kung sino yung hindi benchmark class. Okay? All right, let's interpret this now. I-clear ko lang drawings class quickly. Although na-interpret na natin dati to, no? Just reviewing that it pays to review class kasi, lalo na maybe first time na-meet itong concepts na to. All right, ito si race white class. In the first place, hindi siya significant, ha? Okay. All right, so this is a meaning, no? Ibig sabihin nito, okay, i-explain ko in a while kung ano ibig sabihin. But if this was significant class, ano ibig sabihin nitong 0.10 o 0.11, i-round off ko na lang. What does that mean? On the average class, how do you interpret that? On the average, white people receive $0.11 more than their non-white counterparts. Okay, so you always interpret this in relation to the benchmark. Okay, non-white counterparts and then ceteris paribus. So ganon. So that's why it's always important. Kung marami kang levels, makikita mo na sino yung wala dito. Yun yung benchmark. Kasi ang benchmark lagi yung alphabetically mauuna pag sinort. Unless i-re-level mo, di ba? We learned that last time. You can change the releveling. What will happen if you change the releveling? Kunyari ginawa kong ang benchmark ko, ang level ko, ginawa kong white, non-white. So ibig sabihin si white ang magiging benchmark. What will happen here is race non-white. Ang lalabas na answer dito. Pero yung coefficient class ito, pareho yan magiging negative lang. It will become negative. So what does that mean? When you read this, on the average, non-white employees receive $0.11 less than their white counterparts. Of course, dapat ganon kasi kung si white employees receive $0.11 more, therefore si non-white will receive $0.11 less. Okay? All right? And then medyo kulang naman tayo sa time. And then here, civil status class. Tapos na tayo dun sa ito class, gender male. How do you interpret this? Statistically significant. Statistically significant at 0.1%, at 0.001. Okay, so highly significant to. So on the average, okay, ano ba yung levels ni gender ulit? Male, female. Sorted alphabetically, who comes first? Female. Female is your benchmark. Okay? So when you get the result here, lalabas gender male. Okay? So I hope hindi na kayo nagugulat kung bakit gender male ang lumalabas dito. No? Hindi gender female. But if you want gender female, pwede rin. Okay? Just re-level it. Okay? Kasi default leveling lang naman yan. Okay? But you can change the leveling if you want, no? So, very flexible si R. All right? Again, how do we read this? On the average, male employees receive $1.76 less than their, more than their female, male employees receive $1.76 more than their female counterparts, ceteris paribus. Okay, so the question is, meron bang discrimination to? Discrimination. There's a way to answer that via interaction. Okay, so we'll take a look at that next time. Yung interaction class. Kasi dito hindi natin malalaman kung may ano ba, may nepotism ba. Ang sinasabi lang diyan, male employees receive $1.76 more than their female counterparts. Okay? Walang, yun lang, class. And we cannot judge whether there's tawag doon? Forget the word. Ano yung class? Ano sinabi ko kanina? Merong anyway, nakalimutan ko kagad. Ay, discrimination pala ang sinabi ko. Okay, and then this one, negative 0.46. Okay, so it's not significant. But if it's significant, on the average, single employees receive negative $0.46 less than their married counterparts, ceteris paribus. Okay, so that's how you interpret that. Now, how do you interpret the intercept? The intercept is interpreted this way. It's the value of your dependent variable hourly wage, okay, when all your predictors are zero. Okay, so let's read into that, no? So it's the average, the average hourly wage is negative 3.39. If there's no education, zero experience, zero tenure, walang number of dependents, who is non-white, who is female, and who is married. Okay? Bakit ganun yung sinabi ko, class, ito sa race, gender, and civil status? Kasi class, if race is equal to 0, diba? Sabi natin, ang intercept, it's the average value of your hourly wage dependent variable when all your predictors are equal to 0. So, what does it mean for race y to be 0? E di, 0 siya, diba? Diba yun ang ibig sabihin ng benchmark? Sino ba yung benchmark, class? The non-white. Kaya sinabi ko, who are non-white, female, and married. Kasi ito yung tatlong factors natin. Okay? But of course, we don't put any physical interpretation or practical interpretation to your intercept or practical implication. Bakit? Kasi negative yan, no? It doesn't make sense that the hourly wage is negative. Does that mean that it's the employee who will be the one coughing out that $3.39? Sila pang magbabayad sa company, sila nagtatrabaho. So it doesn't mean anything. However, class, so when we create our equation, diba? Our model, no? So I'll just quickly listen, class, tingnan nyo yung model natin, hindi ko isusulat, ha? So hourly wage is equal to negative 3.38. I-round off ko na lang, negative 3.39. Okay? Now, if intercept is not significant, sinasama pa rin yun, class. Okay? Sinasama pa rin siya. Then plus 0.57 times education. And then plus 0.14 times tenure. And then 1.76 times gender. And then negative 0.45 times civil status. Okay? Plus epsilon sub I. Okay, so in other words, class, ang sinama lang natin dito yung mga, okay, let me stand corrected, no? So you can include all the, hindi, okay na yung class. Okay na yung sinabi ko na ang sinama lang natin sa model natin are the significant predictors. Alright? Now, ito class, medyo mahabang discussion to. I-discuss na lang natin next week. I just would want to review what we did last time, class. Okay, kasi umabot kami sa basic ng stepwise. Alright? And I want to discuss that with you, especially for those of you who were not present in class last time. Now, is this the final model? The answer is no. Okay? There's a process called stepwise regression. So si stepwise, ang gagawin natin dyan, okay, kasi possibly, bakit hindi significant yung iba? Possibly, may, ano ba yung, may correlation, no? May correlation sila. So, nagko-compete sila sa pag-explain kay hourly wage. And that might result into both of them not becoming significant. Iba meron tayong ganung data. Sino yung, which one has, very relatively high correlation? Diba? Ito, si experience at saka si tenure. Yeah, both are independent variables. And you can see here experience and tenure. Although dito class, experience, ito yung class, no? Experience is significant at 10%. Si tenure, okay. So possibly nagkakaproblema. Possible lang possible lang. But we will have to check that with VIF. All right. So we said last time class that magsi-stepwise regression tayo. There are two types of stepwise regression. Meron forward, merong backward. Gagamitin natin class yung backward. Sa backward stepwise regression, you start with the full model first. Ito, ginawa na natin. Tapos, we're going to remove one at a time. One at a time kung ano yung variable na pwedeng mo nang tanggalin. One at a time instead of remove all the other insignificant at once. Okay? So di ba dito ang lumalabas lang, tatlo lang yung significant na predictors natin. Discounting intercept kasi si intercept hindi naman talaga independent variable yan. No? All right. So what do we do, class? We will have to remove, of course, ang i-remove natin from one of the insignificant predictors. And madaling malaman yan, class. Ang hahanapin natin dito, yung sa t-value. The lowest absolute value na t. Take note, absolute value. Okay, t, check the t-value, absolute value, yung minimum niya. Minimum. So ano na ba yung mga 0.257, even without checking kung significant. Kasi notice ka yung mga significant, matataas yung p-value nila. 6 yan. Okay. So 0.257, sino pa? 1.566, negative 1.34. Now take note, I'm choosing 0.257 and not negative 1.566. 556. Kasi dapat yung absolute value class, no? We disregard the negative sign. So race white class will become your leaving variable. Aalisin natin yan and maintain the others. Okay? So last time we reached up to this one. Nag-model 2 tayo, no? So what happened? LM pa rin. We removed race. Okay? Wala na si race class. Take note. Yan. Race has been removed. It's almost time class. Run lang natin to. Okay? So copy nyo lang class yung model 1 sa taas. Let's change the model 2 gawin natin. And then remove yung race. Same everything. Yung summary niya, 2. Okay? So here, before we run model 2, we can see here that in the adjusted R squared, 36.19% of the variability of hourly wage, yung dependent variable natin, can be explained by our model. Kaya nyo explain 36.19% of the variation. Okay? What about the 64%? Ibang variables yung makaka-explain nun. Okay, here class, if you run this, I hope you were able to follow, class. Yung mga not here last time, sabi ko, copyhin nyo lang yung code sa taas, ano? Palitan nyo lang yung pangalan, tanggalin nyo yung race. Okay, and i-run nyo, i-summarize nyo rin. What do you find now here? Notice the R's, adjusted R squared, it increases 3631. Dito 3619. So ibig sabihin, this model improved as far as explaining the variability of your dependent variable. Notice na mas konti class yung variable nito, ha. So it doesn't mean, and by the way, class, ang R squared nito, 37.03, will always be lower than the R squared of the model that has the most independent variables. The more the predictors, the more the R squared is. That's why we don't use R squared. Kasi it doesn't mean na maraming variables, okay na yun. No. Kaya nga may stepwise tayo eh. Kasi dapat may mga kailangan tayong tanggalin na hindi naman nakakatulong i-explain si hourly wage, no? So dito, class, yes, 37.03, mas mababa talaga expected yung R squared nito. Pero yung adjusted R squared niya, take note, mas mataas. And this is what matters, class. That's why I said, when you assess the model, you look at the adjusted R squared and not the multiple R squared. Next meeting, titingnan natin kung paano na-compute to, no? So if you need to leave class, just go ahead. I'll just finish this up for just a recap, no? Para sa recording. Okay. So, ang question natin, class, how do we decide which is better, model 1 or model 2? In terms of adjusted R squared, mas okay si model 2, no? Pero in terms of R squared, talaga mas okay si model 1 kasi mas maraming predictor siya. Good thing, we can do what we call ANOVA. Okay, share ko na lang to para mas mabilis. Control C. Control V. Okay? Analysis of variance. So, ang null hypothesis dito, class, is, okay, ito linagay ko. The null hypothesis. The race variable, which we removed here, is equal to 0. Anong ibig sabihin ng class? Yung, not actually the race, the beta, no? The beta. Beta 6 yata si race, no? Yung estimate for race is equal to 0. AKA, ano ibig sabihin nito? Yung restricted model is better. Okay, may ginamit akong term, no? Ano yung ibig sabihin ng first unrestricted and restricted? If you're comparing two variables, si unrestricted is the model with more predictors. Yan, unrestricted, no? So therefore, the model with less predictors okay, is your restricted. Okay, and take note, class, isang variable lang tinignan natin. Ganun stepwise, one at a time. So, ang sinasabi natin dito, ba't ka pa maglalagay ng race na variable? Hindi naman mag-explain ng ano yan, ng hourly wage. So let's see, class, let's see. Run natin tong ANOVA na to, analysis of variance. And you can see here, class, that the p-value is 0.79. Okay, so kino-compare niya, no, si model 1, class, yung may gender. Ito yung unrestricted. Si model 2, si model 1 yung may race, class, no? Wrong pickup of variable. Yung may race, unrestricted. Pangalawa, walang race. Okay, restricted. So you notice that the p-value is 0.79, napakataas, class. Therefore, we failed to reject the null hypothesis that the restricted model is better. Fail to reject, class. Ibig sabihin, mas maganda nga si restricted model. Okay? Mas maganda si restricted model. Alright, as an assignment, class, I'll not collect it. So meron na tayong bagong model, di ba? Si model number 2 na. So tingnan nyo to, class, si model number 2 ito. Ano ngayon dyan yung stepwise ulit tayo, no? Backward. Ano yung leading variable? Kasi so far, ganun pa rin, no? Tatlo pa rin yung significant. Si experience, 1 star pa rin. No? So, tuloy pa natin while there are non-significant. So, ang leading variable natin yung class is like to take a look at the t-value. It should be number of dependents. Okay? So, kindly, ano nyo lang class, i-practice. Mag-leading variable kayo, magtanggal kayo. Tapos, after removing, okay, mag-ANOVA para malaman nyo kung okay ba na tinanggal yung variable na yun. Okay? And then, until such time class that you only have all are significant predictors. Okay. So with that class, we end our discussion. Next meeting, we're going to discuss yung R squared, adjusted R squared. Okay. And then we're going to continue with the stepwise regression. So we're going to look at that more. Okay. All right. And then if we can reach up to interaction, we'll do that. Okay, let me stop recording.